The send-off of NASA's Explorer tests was like the beginning of an astounding excursion into space. It demonstrated the way that we can keep an eye on Earth, as well as everything in our nearby planet group and beyond. Even after 46 years, these great rockets are still providing researchers with new and astonishing data about space. Despite the fact that their memory is 3 million times smaller than that of our cell phones, and they're multiple times slower than our quickest 5G web connection, these incredible tests still lead the way in exploring space. Now, Explorer 1 has made an unbelievable discovery in interstellar space, one that challenges everything we thought we knew about the universe. It found something so rare that scientists are left scratching their heads. But what exactly did it find, and how does it redefine our understanding of the universe? Let's find out. #### background history. On a unique day, September 5, 1977, from a place called Cape Canaveral in Florida, something astounding occurred. Voyager 1 began its journey into space. Launched by a powerful rocket called Titan III/Centaur, only 15 days later, on August 20, 1977, Voyager 2 joined in starting its adventure into the universe. Their main task was to explore the giant gas planets in our solar system, like Jupiter and Saturn, along with the moons that orbit them. But guess what? These space voyagers ventured far beyond their original mission. They traveled into our vast cosmos, breaking numerous records on their extraordinarily long journey. They have been operational for longer than any other spacecraft and have traveled farther from Earth than anything humans have ever made. They even wandered into a region known as interstellar space, akin to entering an entirely different part of our universe that nobody had explored before. These space trailblazers, Voyager 1 and Voyager 2, are now over 12 billion miles from us. Yet they continue to astound researchers with the incredible discoveries they are making out there. Recently, they found something so startling that no one saw it coming. The Voyager twin probes have done some remarkable work over the years. They observed the moons of Jupiter and Saturn and completely astonished scientists. People used to think these moons were barren and filled with craters like our moon. However, they discovered that these moons are buzzing with activity. Voyager 2 was the first of the twins to pass by Uranus in 1986, and just 3 years later, it zoomed past Neptune. Interestingly, it is the only spacecraft to have ever done that. As these spacecraft continued their astonishing journey, NASA used several clever tricks to ensure they kept working. They turned off some unnecessary components and heaters to conserve power, allowing these spacecraft to keep pushing on until at least 2030. For the scientists and engineers who have been part of this incredible journey from the beginning, it's a mix of happy and sad emotions. They worked hard, and just when they thought the Voyager missions were nearing their end, a stunning revelation emerged from space data transmission and discoveries. The information sent back by Voyager 1 and its twin spacecraft has become a treasure trove for researchers. They have led to numerous discoveries and reignited interest in space. These spacecraft were built with extreme care, like sturdy stages, so they could take clear pictures and collect data while zooming through space. Even before they reached the outer planets, their images were already blowing scientists' minds. Voyager 1 began sending pictures of Jupiter, even while it was still far from the planet. The team at NASA's Jet Propulsion Laboratory was thrilled when they saw the first images of Jupiter's swirling clouds and the famous Great Red Spot. However, the turning point came when the explorers found something astonishing on Jupiter's moon, Io. This moon, undoubtedly larger than Earth's moon, turned out to be the most active volcano in our entire solar system. Voyager 1's instruments detected unusual signals from Io, and the images they took showed massive volcanic eruptions, with material being expelled into space. One of Io's volcanoes, called Pele, erupted incredibly high, higher than Mount Everest, and covered an area nearly as large as France. The Voyager spacecraft took over 33,000 pictures of Jupiter and its moons, showcasing the beauty of Jupiter and the diverse landscapes on its moons. Before this, these amazing revelations had been uncovering extraordinary findings since they began their journey. Another significant treat was discovering that Jupiter has rings, even though they are not very bright. This discovery made Jupiter even more intriguing. Voyager 2 found that Europa, one of Jupiter's 53 moons, has a thick icy shell more than 60 miles thick. These discoveries made scientists reevaluate what they thought about these distant objects in space and sparked curiosity about whether icy moons like Europa could be places where life might exist. The journey continues. As the explorers left Jupiter, they received a gravitational boost from the planet, acting like a powerful kick that propelled them towards Saturn. This kick was incredibly important because it helped them break free from the sun's gravitational pull and continue into space. Voyager 1 and Voyager 2 then set off in different directions, heading toward new destinations. Voyager 1 came close to Saturn's moon Titan, which is surrounded by a thick, orange haze. Researchers became curious about Titan's secrets and studied its complex chemistry. Voyager 1 then ventured away from the other planets and began moving beyond our solar system. Meanwhile, Voyager 2 had some incredible adventures as well. In 1986, it flew by Uranus and discovered 10 new moons, adding to the total count. 3 years later, it reached Neptune, revealing astonishing information about this distant ice giant. Voyager 2 even measured winds on Neptune, reaching speeds of 1,000 miles per hour, the fastest winds ever recorded on a planet in our solar system. When the spacecraft approached Neptune, just 2,980 miles away, it provided us with new and mind-blowing insights about this far-off world. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar system, with temperatures dropping to a frigid -391 degrees Fahrenheit. Triton also had cold ice volcanoes that ejected nitrogen gas and icy materials into its thin atmosphere. All of these discoveries helped us appreciate how unique and fascinating the planets and moons in our solar system can be, even the most distant ones. The role of gravity assists. Gravity assists played a crucial role in pushing the Voyager missions along. Think of it like this: Voyager 1 and Voyager 2 were powerful spacecraft on a significant mission to explore the far reaches of our solar system. To reach these distant places and gather essential data, they needed a little help beyond just their engines. Here's where gravity assists come in. It's akin to a space dance. Instead of relying solely on their engines, these spacecraft performed a cosmic dance with some of the solar system's giant planets. They used the immense gravity of these behemoths to slingshot themselves forward, conserving fuel and gaining the speed necessary to visit multiple destinations. The concept behind gravity assists, also known as gravitational slingshots, involves gaining speed from a planet as the spacecraft passes by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with gravity to match its size. The brilliant minds at NASA's Jet Propulsion Laboratory ensured that Voyager 1 swung past Jupiter at just the right angle and speed. Jupiter's gravity tugged at the spacecraft, making it go faster, like a space power-up. However, there is an art to this maneuver. If Voyager 1 had approached Jupiter incorrectly, it could have resulted in a catastrophic failure, sending the spacecraft off course. Fortunately, the NASA engineers mastered it, and the celestial dance with the planets was a huge success. The level of precision required for these maneuvers is astounding. But guess what? The ingenious scientists and engineers who orchestrated this astronomical dance didn't just get it right once. They did it multiple times. Thanks to these gravity assists, Voyager 1 and Voyager 2 embarked on this incredible journey through the solar system. For example, Voyager 2 utilized gravity assists from Jupiter and Saturn to speed up its journey to Uranus and Neptune. These space maneuvers played a vital role in making the grand tour possible. Voyager 1 made it to interstellar space, and Voyager 2 wasn't far behind, all due to the incredibly precise gravity assists they received. The Deep Space Network. Even though the Voyager missions utilized gravity assists to navigate through space, another significant factor contributed to their success: the Deep Space Network, DSN. Think of it as a space telephone line that kept us connected to our daring Voyager probes as they ventured into the unknown. What exactly is the Deep Space Network? It may not be as glamorous as a spaceship, but it is crucial. The DSN is like a vast network of radio antennas located in different parts of the world, including California, Spain, and Australia. These giant dishes, some as large as 70 meters across, act like space bullhorns, helping us communicate with spacecraft that are far out in space. Let's dive into its role in the Voyager missions. The Voyager spacecraft, equipped with cameras and sensors, served as our eyes and ears in space. To understand the data they sent back and guide their actions, we needed a robust communication system, and that's where the DSN came into play. Imagine Voyager 1 sending a message back to Earth from the outer reaches of our solar system. It's a faint signal traveling incredibly fast through space. When it reaches Earth, it is very weak, but the DSN's enormous antennas are ready to capture that signal. They lock onto Voyager's whispers and turn it into information that researchers can utilize. The DSN doesn't just receive signals. It also sends commands. As the Voyager missions evolved, researchers and engineers needed to adjust their plans or instruct the spacecraft on what to do next. They transmitted these orders through the DSN, shooting them into space like a beam of light which the Voyager probes received. The two Voyager spacecraft continue to send data back to Earth, allowing researchers to study the cosmos and learn about distant worlds. ####, the astonishing new discovery. Now, let's talk about that astonishing discovery made by Voyager 1. For years, it had been exploring interstellar space, a region beyond the influence of our solar system. In its journey, Voyager 1 detected something remarkable: a unique wave pattern caused by the interaction of the solar wind and interstellar matter. This pattern revealed a complex structure in space, indicating that our solar system is not just a simple bubble floating in the vast cosmos. What does this mean for us? It challenges previous notions of how solar systems are shaped and how they interact with their cosmic surroundings. Scientists are reevaluating models of interstellar space based on these findings, opening up a treasure trove of new questions about the nature of the universe. Understanding these interactions may lead to breakthroughs in astrophysics and help us comprehend the birth and evolution of stars and planets. #### Conclusion. As we reflect on the astonishing discoveries made by Voyager 1 and Voyager 2, we realize that they are not just machines. They are our ambassadors to the universe, showing us that there is still so much more to learn. With their continued journey through the cosmos, these spacecraft remind us that the quest for knowledge knows no bounds. Their mission has just begun, revealing secrets that have eluded humanity for centuries and igniting our curiosity to explore further into the cosmos.